Good morning everyone. Welcome to the Analog and Digital Communications Lab. Now I am going to explain about the third experiment in this lab, that is frequency division multiplexing and de-multiplexing. And if you are aware about the multiplexing technique, you will understand the importance of multiplexing in communications. If there is no multiplexing in communications, then there is no existence for the modern communication. So there is the frequency division multiplexing and time division multiplexing. These are the starting multiplexing techniques in this analog and digital communications. At the same time, coming to the definition of frequency division multiplexing, here you can see the black diagram. The first one, here you can find these are the inputs. So at first we switched on the power supply, and this is the audio frequency signal generator. It is going to produce 1 kHz signal, and there is another message signal, that is AF2. This AF2 is going to produce 2 kHz message signal. These two are low frequency signals when compared with the clock. This one is the clock generator. This clock generator is going to supply to the both the multiplexing side and the demultiplexing side. At the same time, you must understand why we are using these what we call modulators at the input terminals of the multiplexing is, at first what we are doing is we are going to supply AF1 to the AF1 input, AF2 to the AF2 input, and you can find that here this one is the frequency modulator 1, and the internal carrier it is going to produce is 10 kHz signal. At the same time, in the second part, that is a same frequency modulator, and we are going to call it as Y, and it is going to produce 20 kHz signal. And here at first we are going to supply the AF input 1 to the AF input, and another input from AF2, and before going to supply AF1 and AF2, let us check the outputs. Let us check the outputs, and after ensuring the outputs from the AF1 generator and AF2 generator, then and only then we need to supply to the FM modulator 1 and FM modulator 2. Let us connect to the DSO. Here positive, this is going to connect it to the positive terminal of the DSO to the probe, CRO probe. Now, right. So now you can see by making automatic adjustment and or manual adjustment, you can find the AF1 signal. So now we are getting the output from the AF1 generator. Next, I'm going to connect or check the second one. Second one is nothing but AF2 output, and we will adjust the input parameters, the amplitude and amplitude of the signal. And here if you observe, there is possibility for us either to increase the amplitude of the signal or decrease the amplitude of the signal depending upon the requirement. And again, let us check another input, that is a clock. Either we are getting a perfect clock or not from this. So yes, we are getting the clock with little noise. Okay, it may not affect the output. So we are getting all the input signals. Right. Now let us apply all these inputs to the modulator, FM modulator. Okay. Here at first AF1 is applied to the first modulator, AF2 is applied to the second modulator, and then we need to check the outputs. Here, if you see that from here you need to get the FM modulator output, that is FM1. So you can take any common point for the ground, and I connected the output of the FM. Now let us check either we are getting FM or not. So here we are not getting clear FM signal, so that we need to adjust the amplitude of the message signal so that we are able to get the required FM signal. So at some particular instant of voltage we are getting the FM signal. Let me stop at this, and you can see that there is a variation. Here high frequency is there, here low frequency is there, or else again you can modify the output by varying the amplitude of the signal. At the higher voltages of the message, we are getting the distortion. So in the FM signal, so I am tuning this probe to get a smooth FM signal, a smooth and clear FM signal. Okay, somewhat better, yeah, okay. Here low frequencies, here high frequencies, and again I am going to check the carrier from the FM modulator 1. If I am going to remove the message signal input and I am going to check the output of the FM modulator, then you can get only the carrier signal. So this is the internal carrier that is generated by the FM modulator 1, right? So that is completed, and again let us check the output of this FM modulator 2, and here we need to vary the amplitude of the message signal in order to get a clear FM signal. Now let us check whether we are getting FM signal or not. Yeah, we are getting here high frequencies, here low frequencies, or we can make it very clear also. Yes. Yes. So this is the FM modulator 2 output with you can see that clearly. That is the FM modulator 2 output. Now let us apply these two. That means output of the modulator 1 and output of the modulator 2 to the multiplexer. At the same time, you must supply the clock pulse, and we know the definition of the mux or multiplexer. Okay, it is going to select one output from the 2 power n number of inputs. Here, for every 2 selection lines, there will be 1. So, the number of selection lines is going to depend upon n value. So that now let us check the output of the FDM, that is the frequency division multiplexing, and this is all about what we call the FDM output. And if you want to know the definition of the multiplexer or frequency division multiplexing, frequency division multiplexing, what we are doing is there we are going to supply multiple number of inputs. Here we are supplying multiple number of inputs, that is message signal 1, or this is the modulated signal 1, this black one, this is the modulated signal 2. These two are supplied as input to the multiplexer, and any one of that is going to be selected as output. That is possible with the clock pulse. For every one clock pulse, one input is going to be selected. Here the clock pulse is going to act as selection line. And then here you are getting the FDM. Simply we can define the frequency division multiplexing as in FDM the channel is going to be divided into unoverlapped. It is going to be divided as unoverlapped bands. That means the bandwidth that is available in the channel, is going to be divided as unoverlapped bands, and then multiple inputs are going to transmit through the unoverlapped bands, and then we are going to get this signal which we call frequency division multiplexed signal. And now let us see the operation of the demultiplexer, how it will works. Okay, now demultiplexing, the definition of demultiplexing is nothing but out of one input, for the given one input, it is going to make it as 2 power n number of outputs, and the same clock pulse need to supply here, so that we are getting synchronization with the transmitter. So if there is a synchronization with the transmitter, then we are able to achieve, then we are able to what we call do the communication. We are able to communicate in a live manner or in synchronization manner. Synchronization means whenever transmitter sends the information, immediately the receiver need to receive it in the same instant of time. Now let us check the output from AF1. This is simply FM demodulator. This is the FM demodulator. As we are aware, there is in FM the noise effect is very high, so that by using this phase lock loop adjuster, we are able to control the level of noise in the demultiplexer, in the what we call in the FM demodulator. Now I connected the output of the FM modulator one. Okay, let us see either we are getting the output or not. In a yes, it is coming. So this is nothing but this is the equivalent output of AF1. Initially we supplied this message signal to this receiving side, and after applying the demodulation, we are extracting the required message signal. This is the required message signal AF1, and we can adjust it by using this PLL adjuster. Okay, you can adjust it. If any distortion is there, by varying this, you are able to adjust the shape of the message signal, and we try to make it equivalent to the supplied message signal. Now later we can apply the same, that means the output of the second output from the demultiplexer to the input of the FM demultiplexer, FM demodulator. Now let us see either we are getting the output or not. Yes, we are getting the output, but with lot of distortion is there. So we can make it equivalent to the message signal by adjusting this PLL adjuster, but anyhow we are getting just nearer signal with a lot of distortion. So to overcome the same, we require extra circuit. So